In the wake of COVID-19, many students, some worried for their health, and others just wanting to avoid the commute out to UBC, are pushing for lectures to be cancelled and for the remainder of this semester's instruction to be carried out online. Although many students were excited by this prospect, I was not one of them. Just the idea of doing classes online gave me so much anxiety. I was sure that I simply wouldn't be able to concentrate if I was watching lectures online, and in fact, this fear of online lectures is not unfounded. As Spooner et al. From Harvard University's Department of Psychology summarizes, multiple peer-reviewed studies have displayed that university students report mind-wandering and lapses in attention while viewing videotaped lectures. And this tendency towards mind-wandering and lapses of attention have been shown to result in poorer learning. Spooner et al. Asked what could be done to minimize these problems. To answer the question, the researchers looked to several recent studies that explored the use of interpolating extended study sequences with memory tests. Interpolating means to insert something of a different nature into something else. So in this context, it means they looked at studies where long studying sessions are broken up by memory tests. Specifically, Spooner et al. Listed studies where participants learn lists of words, face name pairs, and prose passages with interpolated memory tests. However, Spooner et al. Found their hypothesis that interpolated testing helps students attend and to retain lecture contents had never been directly tested, so they got to work to fill this research gap. They did so through 2 experiments. In total, there were 80 participants across both studies, 32 in the first experiment and 48 in the second experiment. All of the participants were Harvard undergraduate students. In both experiments, the participants were told they would learn a 21-minute excerpt from a first-year Introduction to Statistics lecture. The students were given lecture notes and slides and told to learn the lecture materials as they normally would if it was a class they were in. They were shown a video lecture and told that the lecture would be broken into 4 5.5-minute segments. After each of the segments, the participants were instructed that they would have to do 6 math problems for 1 minute. After this, in segments 1 through 3, they would either do 2 more minutes of math problems. This was called the non-test phase. Or they would have to do 6 questions on the lecture material for 2 minutes. This was called the test phase. The students were told that there would be a cumulative test at the end of segment 4. Although the students were told that the kind of activity they would be doing in each segment was randomly generated by a computer, they were actually placed into preset testing schedules. In the first experiment, half of the students received only the 2 minutes of math problems after the segments 1 through 3 and the cumulative test at the end. They called them the non-tested group. And the other students were given 2 minutes of testing on the lecture material after segments 1 through 3, as well as a cumulative test. They were called the tested group. Before the cumulative test, the students played Tetris for 5 minutes, and then indicated how much their minds had wandered, how much they felt their mind wandering had increased as the lecture progressed, and how anxious they were about the cumulative test on a 7-point scale. An answer of 1 meaning not very much, through to an answer of 7 meaning very much. The second experiment was almost the same as the first experiment, except they added another condition. Participants were informed that instead of having to do 2 minutes of math or answering questions, they might also have to spend the 2-minute period being shown the 6 test questions and their answers. The researchers called this the restudy phase. This group was also tested in the cumulative test at the end of the 4 segments. They got to see the same questions as in the tested group, but they also received the answers at the same time. So they got even more information than the tested group, but they didn't have to work for it. In experiment 2, participants still had to rate their anxiety and how much they mind wandered, and additionally, they had to rate how mentally taxing they found learning the lectures. Furthermore, to better assess mind wandering, the students were asked if they were mind wandering at random times in the middle of each segment. Additionally, to assess more concretely how negative or positive the participants' feelings were towards the cumulative test, participants in Experiment 2 also completed the 20-item positive and negative affect schedule before the cumulative test. Students in the tested group reported having experienced significantly fewer bouts of mind wandering, and the occurrence of mind wandering was significantly less likely to have increased as the lecture progressed in comparison to the non-tested group. Additionally, students in the tested group took many more notes than students in the non-tested group. Also, the tested group answered significantly more questions on the material they learned in Segment 4 correctly than the non-tested group. On average, the tested group answered 84% of these questions correctly, compared to the non-tested group, who only got 59% of these questions correct. In the second experiment, students in the tested group, on average, reported mind wandering on only 19% of probes, compared to the restudy group, who reported they were mind wandering on average of 39% of probes, and the non-tested group, who reported mind wandering at about the same rate. However, regardless of what condition the participants were in, mind wandering significantly detracted from the students' comprehension. The intensity of the influence of mind wandering on comprehension was the same regardless of the participant's condition, suggesting that although testing helped lower occurrence of mind wandering, testing did not help to curb the amount that mind wandering interfered with learning. As in Experiment 1, those in the study group took significantly more notes. They took notes on about a quarter of the slides. The non-tested group, however, took an average of notes on 7% of the slides. And the restudy group only took notes on 9% of the slides. Again, participants in the study group got many more questions about the fourth lecture segment correct. They got an average of 89% of these questions right, in comparison to the non-tested group, who got 70% of these questions right, and the restudy group, who only got 65% of these questions correct. Results yielded no other significant differences between the restudy and non-tested groups. Therefore, we can conclude that it was the tests, not the mere re-exposure to the lecture material, that got students to focus on the lecture in a way that increased note-taking, reduced mind wandering, and consequently facilitated learning. The researchers found that students in the tested group reported significantly less anxiety towards the cumulative test than students in the restudy or non-tested groups. Furthermore, the tested group participants also reported on average 12 out of 50 on the negative affect subscale, which was significantly less than students in the restudy group who scored 22 out of 50, or students in the non-tested group who scored an average of 17 out of 50. Furthermore, after the lecture, students found that learning the lecture was less mentally taxing when they were in the tested group compared to students in the other two conditions. In accordance with their hypothesis, Spooner et al.'s results demonstrate how interpolating online lectures with testing can promote speedy and efficient learning of lecture material by reducing mind wandering, increasing note-taking, and thereby facilitating learning. Looking at the cumulative test as a whole, the students in the tested group also scored better across the board than students in the other groups. They got an average of 90% in the cumulative exam, compared to the restudy group, who got 76%, or students in the non-tested group, who only got 68%. Additionally, interpolated testing also helped to reduce the students' test anxiety and their subjective estimates of how cognitively demanding learning the lecture material was. Therefore, we can say that interpolated testing might not just help students learn better, but also improve their subjective experience of learning by reducing their anxiety and making the learning feel less demanding. Testing helps students retain and sustain their attention to the lecture content in a way that discourages mind wandering, which is irrelevant to their task, and encourages note-taking, which is relevant to their task at hand. It is really valuable that the researchers were able to find a way to reduce mind wandering because it is extremely prevalent. In 2010, Killingsworth and Gilbert executed a study where they contacted people at random points in the day and asked them, What are you doing right now? They found that 47% of the time people were actually mind wandering. It's almost as though mind wandering is a default of human beings, which is pretty funny when you consider the fact that the network that is activated in the brain when humans are mind wandering is called the default mode network. The default mode network is active when people aren't focused on a task, so it makes a lot of sense that interpolated testing, which engages the students in a task that's related to the lecture material, would curb mind wandering. I think that even though the researchers don't address the default mode network in their study, it would be really valuable to study interpolated testing with participants in an fMRI so that we can observe their default mode network's activity. The researchers hope that future studies on interpolated tests will be able to describe more precisely the testing parameters which would optimize students' learning of online lectures. They suggest that future studies could look into frequency of testing, the different types of retrieval tests that could be used, and whether these tests must specifically be on the lecture content. After completing their study, Spooner et al. Are optimistic about online lectures as a learning tool, as long as educators are responsible for giving their pupils the best study techniques to make the most of their study time. And now that I know how to increase my own attention while having to do the rest of this semester online, I'm feeling optimistic as well, and a little sick.